Hello dear friends, in this video we are going to see about statistical data analysis using Python library. So what are things we are going to see here in statistics means we are going to see how the descriptive statistics like mean, median, mode, standard, deviation and variance to find, and then how to find the distribution analysis, how to find the correlation and covariance, and how to find the percentiles and quartiles. Then we are going to use this Python module called stats for hypothesis testing. And we are going to use this matplotlib for some visualizations. So that is what the statistical analysis can be doing. So here for that we are going to import the necessary Python library like pandas, numpy, and then matplotlib. In that we are going to use pyplot. And then scipy. From the scipy library we are going to use the module stats for statistics. Then this code is to say that the random number which we generate should be same for every time. Otherwise, if you run every time, it will be creating every time new random number. So we are going to say don't create every time new, always create the same thing. So actually for this statistical analysis, I want a data frame. For that, I want the student ID, a number, study hours, code, gender, and section. So what we are going to do is instead of we give some values, we are going to generate it. So here for student ID card, we are going to say the range from 1 to n plus 1, which means starting from 1, going till n is 100. So we know that the range, the last value minus 1. So we are going to put plus 1. So it will go till 100. Otherwise, it will become till 99. That is why it's now the n value is it is like 100 plus 1. So it will go till 1 to 100. Next, study hour we are going to randomly generate. So for that, we are going to use a normal distribution. So the mean value should be 5 and the variance from the mean value should be 1.5. It is like a value of standard deviation for the n value 100. And so the value should range from 1 to 100. Sorry, 1 to 10. So the range should not go less than 10, less than 1 or greater than 10. So we are going to say the clippers 1 to 10. So the steady hour range from 1 to 10. And so this will be taken for the steady hours with two numbers, floating number. And for scores, that also we are going to randomly generate because scores, for example, if a student is studying more, the scores will be depending on that, no? So for that, we are going to take this steady hour, multiply by 8, and we are again going to use a random normal distribution to generate a little noise because everybody's study pattern. Because, for example, studio student studying for 2 hours and a normal student studying for 2 hours, both are not going to cause the same result because the amount of grasping capability of both of them is different. So to generate a small randomness, we are going to use this along with this, and we are the marks range. We are going to give the range from 30 to 100. So the scores should be from 30 to 100 and with one decimal value. So that is going to be considered here for scores. And the gender, we are going to take a random choice randomly from male or female. Randomly, it will be generating for 100 values. And the section also, it is going to randomly make a choice from ABC for all the 100 values. So this is how we are realistically, somehow we are making a data frame. So just to make this data frame, the structured data in the form of rows and columns, we made it, and we are assigning it in a variable called df. Now the data set is ready. So we can say df.shape will give the number of rows and columns. So total number of rows are 100 and columns are 5. What are they? Study ID, study hour, score, gender, and section. So those are the 5 columns. So df.head of 8 means it will be displaying first the 8 rows. That is what head is. So 0 to 7 means totally 8 rows are displayed. So this is our data frame. So for student with ID 1, his study hour is 5.75 and the score he got is 38.9. And then the person is a female and the section is C. Likewise, we are generating some random data for 100 students. So this is what the np dot random dot normal means. It is like mean value, its standard deviation, and the size we gave. And the clip means the range will be from 1 to 10. So now with this data frame, we are going to do the statistical analysis. First one is we are going to use the function called describe. So describe will give all the statistical descriptions like mean, median, then minimum, and quartiles, no? First 25 percentage, 50 percentage, 75 percentage. So all these details will be taken. So for that we are going to not use for entire thing. For study hour and the score alone, we are going to find the description. So for study hour and for the score, the count is 100. Mean value for study hour is 4.84 and the score is 40. Standard deviation, the amount of spread from the mean is 1.36 for study hour and for the score is 9.46. Minimum value is this. Minimum value for score is 30 and quartile values. First 25% quartile for study hour is this. So this is how a small descriptions like that you can understand. Next one is for individual. For example, I'm going to take only the column called score, assigning in this variable s. For that, we are going to individually apply the statistical value. So for s dot for score column alone. So here is our score column, no? For this score column alone, we are going to find the median, all these things. So mean means we know average, median means we know the center value, mode means a particular value, how many times, the frequency, which value is occurring for more number of times. With all this as 2 decimal point. Standard deviation means from the mean how much value is it is differing. Variance means square of the standard deviation is the variance we know, and the minimum value, maximum value we know that. And the range means the difference between maximum and the minimum is the range. Skewness means is the data is normal distributed or is there is a skew variation in the distribution? Is it left squared, right squared? And kurtosis is also a kind of knowing the distribution value. So this is how these are the values for which we are finding the statistical values. So we have all these values. What is the minimum value? What is the range? What is the mode value? So mode means 30 scores are occurring more number of times. Standard deviation means from the mean value, it is varying with the value with a point which is point of 9.46. So this is how we can understand the statistics. Next one is squeeness. Squeeness means we can understand like this. From the bell, normally curve will be like a normal distributed bell curve. So if the squeeness means it is skewed towards, for example, more students are scoring high value or more students are scoring less value, then it will be skewed towards one particular side. So if the skew value for the score S is containing the scores of that particular data frame. We are finding the skew. If the skew value is greater than 0.5, then it is positively skewed, which means right side there is a tail. So most of the values just accumulated in the left side. Then if the skew value is less than minus 0.5, then negatively skewed, which means the tail is in the left side. So most of the values are in the right side. So which side tail is coming, that side we say skewed, left skewed, like that. And if it is not so, then it is normally distributed. So that is why. So the L spot is normal distributed. So if you see the score, it is the skew value is 0.86. So it is greater than 0.5. So we can say it is positively skewed, which means the tail is on the right side. So the most of the values are accumulated in the left side. So that is what the skewness. And next one is percentile and interquartile range. That is what IQR is. So first we are going to find the quartile value, which means first 25% of value. Then that is Q1. first quartile. So we divide our total score values, the range, into four equal parts. So so we sort it and we divide it into four equal parts. So first 25 part is the first quartile, so it is Q1. Then first 50 percentage of the part, that is Q2, and the next is 75 percentage of the part, that is in Q3. So our interquartile range is subtracting Q1 from Q3 is IQR. So what is the use of this is we can find the outliers, and we can understand the different part of our, so first 25 percentage, 50 percentage of the value distribution. So Q2 will give you the median, the middle part. So first 25 percentage of the data, so we can so we are displaying all this Q1, Q2, Q3 values. And so here you can see the first is 25 percentage is 31.27, then 50 percentage is 38.60, then first 75 percentile is 46. Then I am subtracting Q1 from Q3, we got 14.83. So with this IQR value, now we can find the upper limit and lower limit. So the value which is going beyond this lower limit and the upper limit are outliers. Outlier means abnormal values. So how to find the lower limit is this Q1 value. We got now here the Q1 value. The first 25 percentage of data minus, if it is a lower length, you have to put minus, and 1.5 into IQR value, the difference between Q3 and Q1. And for the upper limit, we have to take Q3 and you have to plus 1.5 into IQR. So this will give you the lower limit and the upper limit. The values which is going beyond the lower limit and upper limit are called as outliers, which means they are the abnormal value. So as we already discussed, the age means the value should be from 0 to 100. If it is going above 100 or below 0 means it cannot be an age. So we generally know the age will be between 0 to 100. So if any values other than this is an outlier. So we can find the outlier. So we are finding from the scores whenever the value is less than the lower limit, and if it is greater than the upper limit, then those are all outliers. So those values alone we are storing in outliers. Now we are specifying the range. So the lower limit, upper limit, and the lower limit. So if you are saying the lower limit is 9, upper limit is 68.3. So whichever value is going beyond that is all outliers. So in this our data we have only one outliers, and the value is 68.4, because the upper limit we have given as 68.3. So whichever value go beyond that is outlier. So in our data set only one outlier is there with the value of 68.4. So this is how we will be doing percentage and IQR specifically to find the abnormal values. Next one is frequency distribution. So for that we have a function grade, and then we can apply. So this we have discussed in the previous videos. For the score column, we are applying this function so that for every grade, for every score, we will be getting the grade. And then we are going to take the unique values, and we are going to re-index with the values of from the value which means from the higher value, no. So a plus a b c like that, and whenever there is a no value, then fill it with 0. So that is what the frequency, and using this frequency we are finding the percentage. So now you can see for the grade how many percentage, how many count is there, what is the percentage. So that's what we are finding. The frequency is the count and the percentage is in the variable PCT. So so this is the index we used. So you can see this. And if there is no value, then it is filled with 0. And then cumulative distribution means first we are going to sort our score, and then we are going to find the cumulative percentage value. So as usual, now how to find the normal percentage, and then and then we are finding the percentage. So what is this NP dot percentiles for the sorted score, comma 50, which means if it is 50 means the score below which 50 percentage students fall. So how many students have fall below 50? That is 38.6 percentage of the students fall below 50 percentage. So that is the meaning of this one. That is cumulative distribution. Then the correlation. Correlation means is there is in a relation between so two different features. So we are taking study R and the score and we want to find the correlation. Correlation means is there is any relationship between study R and the score. That is what the correlation is. So that correlation value we are going to display with the 4 decimal values. So if the correlation is greater than 0 point, so it will be ranging from 0 to 7. So if the value is 0 to 1, if the value is close to 1, it is strongly correlated, positive correlation, which means there is a relationship between study R and the score. So for our score column and the study R, we are going to find the correlation, and we are going to check the correlation if it is strongly correlated or not. So here our correlation is 0.86, so it is strongly positively correlated. So there is a strong relationship between study R and the score. That is the meaning. So we can also display the correlation in the form of a matrix. So between study R and the score, the correlation. So study R and study are highly correlated. Study R and the score is correlated with 0.86. So this is what a small matrix. We said for a 4 decimal value. So here we have 4 decimal value. Next one is group statistics. So what is group statistics means? Already in the previous video we discussed about group by values. Hope you have saw that. So we are going to group our data by sections. Like we have A, B, C, D sections. For the sections, we are going to take the score column and we are going to find the mean, median, standard deviation, minimum and maximum. So that is in the section statistics. So for that, we are going to give the column value. For we are going to find the four, what are the values? 5 values, mean, median, status, aggregation function we are going to apply for the score. So the value the result we are going to get is stored in this section statistics. For every column, we are going to give this as a heading. So then we are going to display it so we can see the heading. And for every section, ABC section, individually we are showing the mean, median and everything. And we can also apply the same thing for gender wise also. Here we are doing the statistics calculate group by for section. Here we are going to do for gender. Same thing, mean and median. So here you can see it is done here. It is done based on the section. Here it is done based on gender, female and male. For that we are finding mean, median and standard deviation. Same thing. The next one is hypothesis testing. Using from the library scipy, we are going to use stats module to do the hypothesis testing. So how much the relation is true, is there is any randomness are found by using this. So we are going to find the t-test and p-test. So t-test is the difference between two groups statistically. So whenever we can compare two groups by using t-test. So the two groups mean value is compared here. So I check the difference between average randomness in the data, whether the difference is meaningful or not. So t-test will give the comparison mean between the two groups. So p-value say whether that difference is actually the real value or it is a random value. For example, if there is a difference, for example, male students are passing 75 percentage and female students are passing 80 percentage. So so that is a mean difference. So if the difference between them is 5, so what is this p-test says is this 5% difference is actually real or it is sometimes random difference. So that is what given by p-value. So t-test says the difference, p-value says is the difference is real or random, something like that. So there is a function called t-test underscore ind which will perform the full t-test and it will give the values for individual value. This is the full test. So this is for a particular thing. What is the t statistics and what is the significance of the difference? So p-value meaning small p-value means then the difference is actually a real difference. If the p-value is larger, then the differences may be because of randomness, maybe luck or something like that. So small p-value is always likely a real difference. Okay, actually there is a difference. So that's what the small p-value. If the p-value is large, then we cannot say that the randomness, the difference is actually a real one. It may be a random value. So here we are going to apply it. So what we are going to do, we are going to get the two data frames, male score as well as the female score. So from the data frame, we are going to take the gender and as male, and for that male we are going to get the score and store in the male score. Similarly, from the data frame we are going to take the female values. For the female values we are going to take the scores and store it in this female store. Now using this library module stats, we are going to apply the t-test. So we know the t-test will help us to find the difference between these two groups mean value. So from that we will get the t statistics value and the p value, so the individual values. So we are male scores mean value and female scores mean value are finding. So then we understand the males. Now we can understand the difference that is in t-test and the p-test value. So we are going to check whether if the p value which we get is less than alpha mean, that is the real value. Okay, really there is a difference. If it is greater than 0.05, then there is no significant difference. The difference may be created because of some randomness. That is what the understanding. So here if you see the p-value is 0.65. So it is greater than 0.05. So we are going to say that there is a no significant difference between two groups. Actually the difference may be because of randomness. So male's average value is 40, female's average value is 39. So the relationship between them is 0.4 and the p-value is 0.65, and we can find the randomness. So t-test compares the two group average. T-statistics says the size of the difference. P-value say the probability difference in randomness. So alpha value we are going to keep as a threshold value, and then we are going to compare the values. So if the value is less than 0.05, there is a significant difference, otherwise no significant difference. Next one is visualization of statistics. What is visualization of statistics means? We are going to visualize the values. So here we are going to take the score value from the data frame and we are going to show it in the form of histogram. So plot is, it is the variable for the matplotlib we saw in the beginning itself. So I'll show it again. So what is that PLT? So if you see here, from the matplotlib, we are importing pyplot. For that, we are giving a small name that is PLT. So PLT specifies the matplotlib library. So using that library, we are going to show the histogram for the score column. So plt.show will give this. And then we can give the title for that graph. We can give the x-axis, y-axis. X-axis we are going to give a score. So you can see here. Y-axis number of students we have given and we are going to show it. So here we are using bins as 10. So the score is grouped into 10 bins, 10, 10, 10, 10. The 10 values are grouped under 1. And next one is scatter plot. So this is the scatter plot. So we can understand as the steady R increase, the score also increase. That is what scatter plot. For that, PLT dot scatter, the value we want to compare with between two attributes. So steady R and the score. And the title for that diagram we have given a study R versus score. So study R versus, that is coming here. And the x-axis we gave a study R and the y-axis is score. Next one is bar plot. So here you can see the bar plot. So what is in the bar plot is, we are going to find the unique value in the sections. So what are the unique value? Here we have three sections A, B, C. So for that unique value, we are going to take the index. That's is given as first value for the bar. So index is ABC. For each section, how many values are there? So that is what given in the values. So you can see for A sections, the count is above 35. So likewise, we are showing and have given title and the X label and Y label. Next one is box plot. So box plot is generally help us to find the abnormal values. So here you can see this is the box plot. Divide the data into quartile 1, quartile 2, median value and the quartile 2. So if this is the upper limit and the lower limit. So it says here only one value goes out of this upper limit. So it's an outlier. So that can be, so here what we did is for the data for the section A, we are going to take the score separately, B separately, C separately, and that is given as the input for the box plot. So for all the three sections, we are finding the box plot. So instead of 1, 2, 3, we are going to give the label as ABC here. So now the label is ABC for A section. What is there is any outlier or something like that we are finding. So in B section alone, there is an outlier. And the last one is we are going to use a pie plot. So plt.pie plot. So here we are going to take the gender count dot values, and the labels are its index like female and male. So the gender count is giving the unique value from the gender. That is what here. So we have only male and female, two things. So two things, and then that is what gender count. How we got the gender count? Unique value under the column of gender. So that is assigned as gen for the gender values, and labels we have given the index, and auto percentage will give you the percentage. So how many percentage are there in female, how many percentage are in then male. So this percentage is a percentage after decimal point one floating point. That's all. So that's all about the statistical analysis. So we saw about all these things. Hope you have understand it. Thank you, ma. God bless you.